So through this video, we are trying to understand about gravitational fields as taught in A levels and IBDP course. So here in this video, we are talking about the Newton's law of gravitation as well as the gravitational field strength, right? So gravitation, all of us know that the earth has a gravitational pull in certain space around it. So the earth is pulling objects through its force of gravity, and that is shown by these arrows. So gravity is a very familiar concept, but there was scientist Newton who told certain very good thing about gravity. He said that any two masses attract each other with a force which is proportional to the product of their masses and inversely proportional to the square of distance between them. He said any two masses in the universe, right? So this is applicable to any two objects, whichever have mass, right? So right now when I'm sitting here, maybe one of my friends is sitting in the USA and I am pulling that friend in the USA through a gravitational force, right? I am applying a gravitational force on all the masses, all the particles in the universe. So, all of us have a gravitational pull on each other. We have a gravitational pull with everything in the universe. Any two particles in the universe, they are having a gravitational pull between them. Now, this is a phenomenal idea. Why? Because we think that we are independent, right? But we are impacting everything in the universe, and the everything is impacting us in a lot of ways. So, coming back to physics, what Newton said, the idea he gave was very simple. If there are two masses, say m1 and m2, at a distance r, right? So the masses are m1 and m2. We are considering point masses here. So masses m1 and m2, they attract each other by a force which is proportional to the product of their masses, right? Inversely proportional to the square of distance. Now this r stands for the distance between the masses and not the radius, right? We have a common misconception that r is always radius. Now, to remove the proportionality sign, to bring an equal to sign, I need to introduce a constant, right? So my equation becomes g into m1 into m2 upon r square, where I know that m1 is the mass of one of the objects, m2 is the mass of the other object, and r is the distance between the objects, not any radius, right? G is the universal gravitational constant, which has a value 6.67 into 10 raised to minus 11 Newton meter square per kg square, right? So things to note here, that one is the universal gravitational constant has this value. Secondly, what do we have to know? We have to know its unit, Newton meter square per kg square. This is the SI unit. And we also have to acknowledge the fact that constant can have units. We sometimes think that constant don't have units. Constant values can have units. So basically what we derived is the force acting on any two objects placed at a certain distance away, right? So this can be used for calculations. If all the other values are known, one of the values is missing, we can find the missing value. Whether it's the value of force, it's the value of mass m1, it's the value of mass m2, or distance r, right? Thing to note here, that mass has to be in kgs, right? R has to be in meters, and in that case, the force comes out to be newtons, right? So this is the Newton's law of gravitation. Now, what is gravitational field strength? So, gravitational field can be visualized as a space in which the effect of gravity is there. Right? So, gravitational field strength is basically a space. So, right now, all this area, this is a space in which the Earth's gravitational field is there. Right? So, this is the gravitational field of the Earth. Now we are talking about the gravitational field strength, how strong the field is. And definitely the field is stronger at different points. Right? So if I mark points 1, 2, 3, right? Point 1 will have a different strength, 2 has a different strength, 3 may have a different strength. Right? So we need some mathematics to be able to comment about how strong the field is. Right? Some mathematics is needed. Now, what is that mathematics? Force per unit mass experienced by an object acting on a small mass placed at a point. So, first part of this definition is force per unit mass experienced by an object. So, what will happen if I take an object and place it at point number 1? It will experience a gravitational pull, right? It will experience a force. At point 2, if there is another object, it will also experience a force, right? At point 3, if there is another object, that will also experience a force. But can we compare different masses having different forces? No. To be able to comment about the strength of the field, we need to know force per unit mass acting, right? Force is acting, but what is force per unit mass? So suppose I am given that at 1, now force per unit mass has unit of Newton per kg, right? Suppose I am given that at point number 1, the strength is 10 newtons per kg. Point number 2, the strength is 20 newtons per kg. Point number 3, the gravitational field strength is 30 newtons per kg. Now, what does this mean? Look at its meaning. This means something really cool, I would say. Right? This means that for any mass I keep at point 1, every kg will be pulled by a force of 10 newtons. For point number 2, every kg is pulled by 20 newtons. Point number 3, every kg is pulled by 30 newtons. So if I have a 1 kg object, at point 1 it is pulled by 10 newton. At point 2 it is pulled by 20 newtons. At point 3 it is pulled by 30 newtons. Right? If I have a 2 kg object, 20 newtons, 40 newtons and 60 newtons. So now what does this tell me? See, if the mass is more at the same point, the force becomes more. Why? Because of per kg it's being pulled by a certain amount. It also tells me that the pull on the same mass is more on point 2 and even more on point 3. So what does that convey? It conveys that field 3 is the strongest, right? Field 2 is a little weak, field 1 is the weakest. Right? So every kg impact we are seeing. So force per unit mass. And because it's force per unit mass, the gravitational field strength is force per unit mass. Or you can also say force is equal to mass into the gravitational field strength. Small g is the symbol of gravitational field strength because it's force per unit mass. The unit is Newton per kg. If you consider the SI base units, it will come out to be meter per second square. Right? We already know the value 9.8 meter per second square. Now think about this. What is the value of this force? If I had placed this object over here, the value of force as found in the previous one was G m1 m2 upon r square. Suppose I am saying m1 is the object, the larger object, say the earth. M2 is the smaller object, right? Say over here, M2 is there, right? It is at a distance of r from the center of the earth. So we will take the distance from the center of the earth in this case, right? Now, what is the force on M2 due to M1? M1 is the mass of the earth, right? So force M2 is this, force between them is this. Now, what is the gravitational field strength at point where M2 is there, right? So what do? I divide force per unit mass. So mass M2 is experiencing this force, right? So force per unit mass becomes what? Gravitational field strength. Force per unit mass experienced by M2 is this, right? Force per unit mass for M2, right? So what does it become? So the value of G becomes, G at any point becomes G M1 upon R square, where M1 is 1. What? M1 is the mass which is creating that field, and and R is what? Distance of that point where we are considering the field strength from the mass which is creating the field. So here M1 was the mass of the earth because earth's gravitational field strength we were finding, and R was the distance from the center of the earth, right? So this is how it is done. Another thing to know about the gravitational field strength is simply the fact that in a radial field, right, where there is an object and the field, we are going away from the object, you notice here the field lines are closer, here they are more far away. Why? Because the field is becoming weaker. So how close these lines are tells us whether the field is stronger or weaker, right? So you see, when you extend these lines further, the distance will increase more because the field is becoming weaker, which is also intuitive. The Earth's pull on us will reduce when we go into space, right? That's why in space, in movies, it's shown that astronauts or things float because the Earth's gravitational pull is very less. Yeah, so as we go away from the object, its field strength reduces, which is also clear from the formula. G is inversely proportional to R square. So when you go away, the G is decreasing. The force per unit mass is decreasing, right? Rise, we can say that we learned about two things. One is Newton's law of gravitation, according to which the force of gravitation between any two objects in the universe is G m1 m2 upon R square, where m1 and m2 are the two masses and G is the gravitational field constant and F is the force of gravity. We also learned about gravitational field strength, which is force per unit mass, or which can be said it is G m1 upon R square, where R is the distance of the point from the center of the mass and m1 is the mass of the object which is creating the gravitational field. If directly the force value is given, we can take gravitational field strength is force upon mass. I hope this video was helpful. If you like it, please follow us on Facebook and Instagram. Thank you so much.